In this video, we are going to talk about two more strategies for verifying trig identities. So the third strategy is using properties of the conjugate is sometimes helpful. So if we have an expression a plus b, we could use the conjugate a minus b to help us simplify. Because we know when we multiply a plus b times a minus b, it helps simplify that middle term. So I'm looking at this particular verification. They look very similar, so choosing a more difficult side may be tough. I'm going to say that this left-hand side is the more difficult side because I have two terms in my denominator versus one term. And we're going to use this idea of the conjugate to help us simplify. So I'm going to multiply the top and the bottom by 1 plus sign. So on top, I'm going to leave it as cosine times 1 plus sign. But on the bottom, I'm going to multiply this out. So I'm going to have 1 and then negative sign, positive sign, negative sign squared. So that's going to simplify to 1 minus sign squared. Now 1 minus sign squared comes from the Pythagorean identity as cosine squared plus sine squared equals 1. If I minus the sine squared over, I know that cosine squared is 1 minus sine squared. So if I say, okay, cosine times 1 plus sine is going to be all over cosine squared. Now I can simplify this cosine with one of these cosines. So I'm going to end with 1 plus sine all over cosine, which is what I wanted it to equal. So the first thing we did was multiplied the top and bottom by the conjugate. And then we use this identity, cosine squared equals 1 minus sine squared, and then we simplified. All right, the last strategy is if we have two fractions, we're going to combine fractions before using any identities. So again, if I'm looking at this problem, it looks like to me like the left-hand side, this is going to be the more complicated side. So my goal is to get a common denominator. So if I have 1 minus sign and 1 plus sign, I'm going to multiply this side by 1 plus sign on the top and bottom, and this side by 1 minus sign on the top and bottom. So on this side, I'm going to have 1 plus sign over, well, we just did 1 plus sign times 1 minus sign, and we're going to get 1 minus sign squared plus 1 minus sign all over 1 minus sign squared. So I'm going to combine this all over the common denominator of 1 minus sine squared. On top, I'm going to have 1 plus 1 is 2, but then sine plus a negative sign is going to subtract. So I'm going to end up with 2 over sine, or 2 over 1 minus sine. Well, we just talked about that 1 minus sine squared is the same as cosine squared. So I'm going to put 2 over cosine squared. Well, this is the same as 2 times 1 over cosine squared. And 1 over cosine squared is secant squared. So it's going to be 2 secant squared. These should be alphas, sorry. So, and that is what I wanted to prove that it equaled, was 2 secant squared. So let's talk a little bit about what we did. So first we got a common denominator. Then we simplified the numerator and the denominator. Then we used the fact that we know that 1 minus sine squared equals cosine squared. Then we also use that we know that 1 over cosine is going to be secant squared. And so those are total two more strategies on top of the two we talked about before, and when it comes to verifying trig identities.